So long problem, but the solution can actually be done efficiently, and I'll show you. Yeah, okay, now to start, notice that e to the x is here, there, and there, and so we could factor it out, and so we could rewrite the given as e to the x times, and then it'll have to be e to the x times, to start, cosine squared x, right? And next I should write plus sine x cos x with the e to the x factored out, but I'm actually going to go to the last guy next, which is minus sine squared x, and then I'll write the plus sine x cos x here, and then close my parenthesis and dx. Now remember, cosine 2x has 3 versions, one of which is cosine squared minus sine squared. So this here is cosine 2x. This here is cos 2x. Now remember, sine 2x is equal to 2 sine x cos x. So if I divide both sides of this by 2, then I see that sine x cos x is equal to a half sine 2x. So this here is a half sine 2x. Yeah? Okay, so just substituting these, I see that my integral is e to the x times cosine 2x plus a half sine 2x dx. So I'm actually going to split them into two integrals, not intervals, integrals, one of which is cosine 2x times e to the x, so cosine 2x dx, and then plus the second guy is going to be a half, and then integral e to the x sine 2x dx. Yeah, so this is correct, right, from what I had previously. And if we call this integral A and we call this integral B, let's try and work on A. Both can be done using integration by parts, but as you'll see in a second, we don't have to do integration by parts on both. There's some nice convenience. Okay, so let's work on A. So A we can see in the form u dv, right? And we know that the integral of u dv by the integration by parts formula is uv minus the integral of v du, right? Okay, now to see A through the lens of u dv integral, we need a u and a dv. So why don't we make u e to the x and dv cosine 2x dx? So if we let u equal e to the x, du is equal to e to the x dx, right? And if we let dv equal, in this, dv equal the rest of the integrand, which is cosine 2x dx, v is going to have to be, what's the antiderivative of cosine 2x dx? V is a half sine 2x. So we see that when we plug in for the right hand side, we're going to get that A, this integral, which is really this integral, right, is equal to uv. What's that? It's e to the x times a half sine 2x uv, right, minus the integral of v du, minus integral of v du. So minus, and I could put the 1/2 in front of the integral, 1/2 integral of what? V du. That's, remember, du is e to the x dx, and then v is right there. I already took the 1/2, so I could write v du as e to the x sine 2x dx, right? Aha! Look here. What did we say b was? B is a half integral e to the x sine 2x dx. I have a half integral e to the x sine 2x, right? And so we see that in this part what we have is a is equal to e to the x, and then I could put the 1/2 right here, 1/2 e to the x sine 2x, and then minus, that's b, so minus all of b. I see where this is going. Do you? Okay, all right. Now, I don't need this, but remember, our given integral is a plus b, right? That's what we're trying to figure out. What is a plus b? Capital A plus capital B. Okay, but from where we're at now, from here, right, if I add b to both sides, I see that a plus b, is equal to, like, just put the b on this side and no more b on the right side, right? So a plus b is equal to a half e to the x sine 2x. Okay, this 1/2 is probably tired of moving around, so but I'm gonna put the e to the x first and then the 1/2 here. It's still in a product. Remember what I said earlier, that sine 2x is equal to 2 sine x cosine x? So if I replace sine 2x with what we know it to be, which is 2 sine x cosine x, and cancel this 1/2 and that 2, a plus b, which is the answer to our integral, is equal to e to the x times sine x times cosine x. Yeah? Okay, cool. This is it for 15, and keep watching. Take care.